This month, the cloud, and most specifically, Amazon Web Services, AWS. I'm sure you've seen lots of commercials for like the NFL and all sorts. They're major cloud provider. They have about 1/3 of the market, I think. So yeah, they're doing good. So generally, like in the future, if you ever need to know cloud, probably AWS is where you would start, right? Like there's also GCP, which is Google. There's Microsoft Azure. Both of them are used a bit. They have a pretty decent share. There's also Alibaba if you happen to be in China. Although there's also AWS in China. Okay, so introduce myself. I'm Ryan. I am a system administrator. I have my information security certification as well. So I do some security work. Um, I am self taught. I didn't go to college or anything like that. I just sort of was like good at computers, right? Um, the advantage of being self taught is that when you figure things out by yourself, um, I think it allows it, like you sort of understand the pitfalls that other people are going to hit when they start learning things. And probably I always feel like I'm pretty good at using metaphors to explain things. So, anyways, I'm Ryan. That's it. Been in IT for about 25 years. Boom. So, a couple things. Feel free to ask questions in the chat. I am somewhat bad at looking at the chat because the text is small and my eyes are bad, but I will do my best. Um, so, feel free to ask questions in the chat and don't say anything in the chat that you don't want to be shared or whatever because the presentation is recorded. And just in general, nothing stays secret on the internet, right? Once it's on the internet, it's there forever. All right. So, it is 8:03. Okay, cool. So we'll start at the beginning, right? We'll start. I guess I decided to start in the year 2001. The cloud wasn't a thing yet, so all the big companies they all had data centers, and those data centers were all connected to each other over the internet. If you were like a top 50 company, you generally had multiple data centers, and then you had your own like network connections between your data centers, and then you also had internet connections into your data centers, right? um, while connections were fast, still limited by technology and physics, right? This, if I remember correctly, it's something like the speed of light can go around the earth in 7 times in a second, right? So unfortunately we're not doing very good speed of light transmissions in the year 2001. So we're a little bit limited by technology and physics. Definitely there was large connections happening, but if you were, let's say, doing business with something in Japan, you had to deal with that round trip time, being, we'll say, 70 microseconds, microseconds, not sure. Anyways, wait, hold on, making sure that wasn't work. Cool. So big data centers, all these companies have them. They still have them, to be honest, right? It's not like they bought all that land and invested all that money into these data centers and then we're like, oh, nope. If they were lucky, some of the bigger ones got to sell their data centers, but a lot of these companies still have them. They just don't have as much stuff in them, right? So the like the .com boom is happening. All these big companies are buying servers as quickly as they can. There is like the pipeline of getting a computer, getting it to your data center, getting the operating system on it, getting it rack and stacked, as that's what they call that. That takes time. They were doing it as fast as they could. We're also at the beginning, 2001, there was virtualization, right? So the concept of taking one computer and running multiple operating systems on it becomes a thing. This helps out a lot when it comes to computers getting faster, right? Because maybe you have an app that runs on the fastest computer possible. In 2 or 3 years, that computer is no longer the fastest computer ever. So you might have to repurpose that computer or something. And the ability to virtualize things, put smaller, take one computer and turn it into multiple small computers, uh, basically allows companies to repurpose a lot of their stuff. And it also allows them to sort of write a lot of tools to create these virtual environments very quickly, right? So ever since systems were invented, system administrators honestly have been writing tools to make building the computer faster, right? As soon as it gets in the door, like they plug in the Ethernet and they run their little scripts, and it changes the banner so it says their company name. It puts their company's monitoring software. It does all this stuff, but there's still just so much stuff that you have to do before a computer is ready to actually run an application. So all the system engineers at all these different companies, they all built their own scripts to quickly customize things for their environment, and they also built a bunch of scripts for doing virtual stuff, right? Like a big thing back then was, hey, let's start taking these big servers that only do one thing and let's scrape the data off them and throw them into a virtual computer, uh, so it can sort of run along other operating systems on a computer, right? So what the cloud sort of begins right around there. So companies basically decide, hey, we're spending so much time waiting to get a computer, and then we plug it in, and then we have to run our tools, and someone's just like, it would be cool if we, instead of we waiting for the computer, there's just we just basically lease a computer on the internet already, right? Um, and so that was a thing. They sort of there was what was called co-location, where you would take your server and put it in another data center, and then there was a point at which it was like, okay, let's stop co-locating. I literally don't care what this computer looks like. You go ahead, buy it, whatever. I will rent it by the hour from you, right? So instead of everyone having their own data center, uh, companies like Amazon and Microsoft were like, we can do this. We're just going to build giant data centers, and you can, rather than you getting the computer and putting your data on it, you just copy your data to the cloud and you use our giant data centers, right? So now, rather than companies writing their own tools, Amazon, Microsoft, all these people are providing those tools. You don't need as many system administrators building computers or systems engineers, because the fact is, Amazon has that figured out, right? That was a problem that Amazon had to figure out for themselves anyways, because back then Amazon was a business that was increasing at a scale that was almost impossible, right? So they already had to create tools for quickly spinning up new operating systems and things like that. And a lot of the reason that they are the sort of the big player is because Amazon.com works pretty much perfectly, and a mazillion people use it, right? So as far as like the whole eat your own dog food term, right? They obviously are, and they're doing good at it. So um, people start using Amazon and Microsoft. And so all of a sudden, the where it used to be company, let's say insurance company, talk to banking company, the all this traffic goes over the internet. Uh, Insurance company is based in Ohio, bank is based in Delaware. Um, and it used to be they would just send, they're sending traffic back and forth. The cloud comes around and it's just like, okay, how about these two companies, rather than having these two data centers, they just put all their data into this cloud, which is generally just like a giant data center. Now, rather than sending it across the country, they're sending, data across this giant data center, and it's a lot closer. So all of a sudden, the internet almost gets faster because all the services that these companies needed, they're also located inside this giant data center, right? So things that weren't necessarily possible because of long round trip times or things like that, all of a sudden become possible. You know, One of the examples I would think about is like it used to be very hard to do what's called tokenizing data, which is like as the data comes in, cutting a piece out and putting another piece in, right? Because by the time you got that piece from way over there to figure out how to tokenize that data, it was gone, right? Like it was just too late. So now though, everything's so much closer. So the term cloud comes from system architecture diagrams. So back in the day, system engineers, right? If you were building a computer application, the first thing you had to do was build a sort of an architecture guide, right? A little diagram, and you would generally use a cloud to represent the internet. And you would use like a little computer to represent a server, a little disk to represent storage. I think it was a triangle as a database. There's all these things. Anyways, that's where it comes from. Google says they invented the term. I'm sure if I Googled it, it would confirm it, but it's not that important. So that's the beginning. Year 2000, Amazon specifically is growing at a scale that is hard to uh, scale, right? So, anyways, all right. So the pros and cons of cloud. All right, so the pros: cheaper, easier, faster, standardized. And what I mean by standardize, uh, like a lot of things. Sorry, somebody said, "Who does Bing say invented the term cloud?" And I would say they would say Microsoft, right? And then I think probably Salesforce, who was one of the bigger, probably one of the first cloud software companies. They would say they invented it. Yeah, it really was sort of just an evolution of technology at the end of the day, though. So, anyways, cheaper, easier, faster, standardized. And what I mean by standardized is all these tools and scripts and things that loaded up your customization for your environment, for your data centers, right? It made things that are a little bit different, and so all of a sudden you're like, oh, I'm trying to get like this database software running on here, but the way we build our servers, like we only use one network connection and this thing requires four. It breaks all my scripts, blah, 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 et cetera, et cetera. Like we don't have that in Amazon Web Services or Azure or whatever. And one of the big reasons is those providers aren't going to change, right? If your database software decided it needed four network interfaces for some reason, they very quickly need to learn how to suffice with just one, right? Because everyone's on Amazon or everyone's on Azure, so it's forcing a lot of these software vendors to standardize to what Amazon is offering, what Microsoft is offering, right? So it's cheaper, and I will say that I should put an asterisk next to this because, like Amazon specifically, we always joke it's very easy to grow inside of Amazon. If you need more storage, you click a button. If you need more of this, you need more of that. It's a little bit harder to shrink, um, specifically with like data, right? Like uh, they do give you the tools to do it cheaper, but it's easy to rack up a bill in Amazon as your business is growing. So easier. I mean, we're going to talk about that and faster. Well, obviously, clicking a button inside of a web UI is much quicker than uh, ordering a computer, waiting for it, rack and stack it, load it, right? So there are some cons though, right? Some industries can't use the cloud, or there's separate clouds. If you are a government agency that handles PII, personally identifiable information, you can't just throw that data in the cloud. If you're a bank, you can't just throw things into the cloud willy nilly. Some industries can't use the cloud, right? And then the information security model is different. And the reason why it's different is because you have to pay attention that even if your server is locked down and secure, you do have to sort of take into account that you don't control it physically, right? Someone theoretically could walk in and just yoink the hard drive out, and there's nothing you can do to stop that. Amazon could make a mistake and, accidentally give everything that's on your server out. So your information security model has to sort of account for that. Like back in the old days, it was pretty easy, right? You'd be like, okay, my server is in this room. You need this key to get in this room, and two people have that key, and they have to sign this sheet to get in, right? Uh, it's not like that anymore in the cloud. But again, some industries just can't use it. .gov and medical, anything that deals with personally PII, personally identifiable information. Generally, they're not allowed to be in the cloud in a lot of instances. So, anyways, that's pros and cons. Is that an example of dynamic scaling? We'll definitely talk about dynamic scaling as I get through this. Okay, so what is available in the cloud? So the basic building blocks for any compute infrastructure. When I mean compute infrastructure, you can imagine in your head like the old 1960s giant warehouse computer. You can imagine it as like uh, more modern like rack of computers, or even now more modern little blades. It doesn't really matter. The basic building blocks has always been: you need a computer, you need storage, and you need network, right? Processor, memory, disk drive, network, boom. um, and with those things you can build other things, right? So you know I'm going to talk about Amazon has Amazon EC2, elastic cloud computing, is EC2. And so if you need a computer, you go into the AWS EC2 interface, and I'm going to show off the interface in a little bit. And you click on EC2, and it brings up an instance, right? You tell it what kind of computer you want, and it spins it up. You tell it what kind of disk drives you want, and it gives them to you. The network is a little. It doesn't ask you a lot about the network because it almost just knows what you want in a weird way. But you do still have to configure a thing like the security rules on the network. Either way, you combine those three things and you build things, right? If I was going to build an actual database server, what would I need? I would need a computer, I would need disk drives, I would need a network. And so Amazon's like, well, we already have the computer. Like, if a customer wanted to build a database server, they could fire up an EC2 instance and load it with database software. But they were like, that seems silly. Why don't we just make a button that orders the EC2 instance, attaches the storage to it, and loads the database software onto it? And so now instead of being like, oh, I need a computer, I say, oh, I need a database. Oh, I need a website, right? I need a web server. And they're like, okay, well, again, like this is a very common thing people need. So rather than like me getting the computer and then loading the software, they just, they have a service where it's just like, we have this already. You don't have to build it. DNS servers, another thing. Content delivery networks. This is we'll talk about Netflix just a little bit. Another interesting scale problem Netflix had, right? Like they went from having no customers having a gazillion, right? And people always say, oh well, they used Amazon Web Services, and that's sort of not necessarily the full truth, but a content delivery network is basically a span of data centers. I will get to that question in a second. Yes. That all have the same content. And based on where you are, it goes to that CDN server and gets the content. Netflix has a giant content delivery network, and people think it's on Amazon. It's not, but they are a Amazon customer. They just don't use Amazon's content delivery network, which is called CloudFront. But again, it's like one of those things where you would have to in the past you had to build this, and now Amazon is just like, you don't have to build anything. So many people build this by themselves that we have just given you a button and it will build it for you, right? There's also machine learning clusters and big data clusters, right? Interesting thing you can do in Amazon Web Services as far as big data is, okay, old days. I need to process a ton of data and get an answer. That's what big data is. Process a ton of data, get an answer. So you like to do this in the old days, you'd have to buy a bunch of computers, get your answer, and then you're like, okay, what do I do with these computers, right? But now you like just go to Amazon. You're like, here's a pointer to my data that I store in Amazon. Would you please run this query on that data? And Amazon looks at the data and says, you know what, I think we'll need about 20 computers to do this. Spins up 20 computers real quick, does the processing, gives you your answer, and then releases those 20 computers, right? Back into the pool. So it's genius. So EC2 stands for so it's actually it's called EC2, but there's two C's, right? So it's ECC, Elastic Cloud Compute, and then RDS is Relational Database Service, which isn't nearly as exciting. EBS is Elastic Block Storage. S3 is Simple Storage Service. VPC, Virtual Private Cloud. Yeah, I did it. I did all the acronyms. EC2 is Elastic Cloud Compute. You're gonna see in any of the compute portions of cloud providers, you're gonna see the word elastic used a lot. Even in Alibaba, which is like the China cloud, they call it ECS, Elastic Compute Service, right? So everyone has their term. So basically the building blocks that we were all doing by hand back in 25 years ago, now none of that. We don't have to do any of that by hand. We click a button, and now all the stuff that we used to do after we got the computers, like load the software and stuff, Amazon does that for you. And they basically like it's amazing. It changes everything. Okay, so I'm going to talk about old days versus what I call cloud days, right? Last 10 years, I would say I would call the cloud days, right? So the old days, like, hey, I have an idea. I will need a web server and a database, right? I'm not going to guess what your idea is, but you you have a lot of data on the back end, and you need a web server, right? So the old days is you would generally talk to an infrastructure architect. This is, or sometimes they were called solution architects, and these were the guys who would sort of translate the business person's requirements over to technical requirements, where it's like, hey, I want to do this, and the infrastructure architect will say, okay, well, uh, based on how much data you need, and they're like, I don't know, and they're like, how many people are you expecting to go to the site, and they're like, I don't know, and you're like, all right, well, here's an architecture, right? Here's a small computer, here's a small database. Boom, we're done, right? So we have two tiny servers for your thing, right? So the architect looks at your requirements and tells you what to buy. You order the stuff. You wait for the computers, which sometimes could be like 6 weeks based on just how the pipeline was, right, at that time, because everybody wanted computers. Uh, so you would get them, and then you would do what's called rack and stack, because you had a large data center full of racks of computers. So you would rack it up. You had a little, almost like a tire jack type thing that helped lift it up if it was a big, like a enterprise 400 or 4000 computer, right? They're very heavy, and they're actually interestingly enough, not only are they heavy, but they're cumbersome, because like the heaviest part is the power supply. So you always go to pick one up and you're like, oh, whoa, right? Like, because the power supply is all the weight and it's always on one side. So anyways, you rack and stack, and then you're like, okay, I have to load configure the operating system, right? Because when you buy the computer, like, yes, when we buy computers, they normally come preloaded with Microsoft or whatever. But maybe, for instance, it's a web server. You're like, oh, I don't want this to be Microsoft Windows. I want this to be Linux because it's a web server. That sort of thing. You can use Microsoft as a web server too. Anyways, and then you do the same thing with the database, right? So you spend all this time loading, configuring operating system, putting tools on, and so anyways, you get everything done, tested good, day one of your website, and you're like, oh crap, this database computer cannot handle the amount of traffic we're getting. Crap, right? And in the old days, I would say, like, a lot of times you would go, like, the system administrator would log in and be like, okay, what is the bottleneck here? Is it memory? Is it CPU? Is it IO? Like, what do we need to do? And then we order stuff, and then we wait, right? And then so we get everything again, right? Okay, everything's on this computer, blah blah blah, and then like a year later, your website isn't getting all that traffic it got on day one, and that souped up database computer is now sitting there, and it's like sucking up $1,000 worth of power a month, but it's only making you like $100, and you're like, man, besides like doing a tax write-off of the depreciation of this computer asset I have, I am not a very good business person, right? So here's the new days, though, right? So I have an idea. I will need a web server and a database. I log into AWS. I click create VPC, and that builds me almost like a little private data center inside Amazon, little private cloud. I click on create RDS and it creates me a database. I click on create EC2 and it creates me a server. I can even sort of decide what image I want loaded on that in advance. They have pretty much all the major operating systems. And then they have a marketplace where it's like, hey, we use like Ubuntu 7 plus Nginx for our web server. And you just go in, you're like, create EC2, put image of Ubuntu 7 with Nginx, and boom, you get it, right? And everybody is using these images, so it's not like it's as customized for your environment as like the old way, right? So day one of your website, and the database computer cannot handle the load. Oh no. So order stuff, wait, no. Literally, you go into the RDS interface and you say, like, you basically say, I would like a larger database instance, And what Amazon does in the back end is they snapshot your old one and then create a new one from that snapshot, a larger, beefier one. They keep the data in sync while this happens, and then when they're done building the new one, they just release the old one. It is now gone. You upgrade your database with a click, basically. Uh, it does. You can't have simultaneous upgrades. So one thing people do run into is they're like, "Oh, I need to upgrade this database," and then like an hour later, they're like, "Oh, I need to upgrade it even more." But there's a certain like lockout. It's usually around 8 hours, so you generally want to overcompensate when you scale up in Amazon. Okay, so anyways, day 365, the website's now sitting there mostly idle. You know what? You go into RDS and you choose a smaller, you just choose your instance and you go, give me a smaller one. And it does that exact same process, except for it snapshots the data into a smaller database. And now the price tag is less, right? One, like, it makes it a lot easier to scale. One funny thing I remember, there's a software called WordPress, and it's very, very popular for people who just want to build like a website with content. Um, anyways, so one like I had a project of rebuilding this WordPress server, right? And it used to be uh, on an actual server, running, and it was like, okay, let's get this thing into the cloud. The funny thing is, so I was like, huh, WordPress always runs slow. Uh, I know why, but also I was like, I wonder how fast I can make it. So I just went into Amazon and, after I got the site running, and I was like, make it faster, right? Uh, give it more CPU, give it more memory. Excuse me. And I just kept doing this, like, until eventually I got to like the 128 CPU, 256 or 512 gigs of RAM, like just an insanely expensive computer. And the best part about the entire practice, first of all, that isn't something you could do in the old days, right? You couldn't be like, oh, what happens if I put this on something faster? Oh, what happens, right? Because you're just wasting. Like in this case, though, you're just releasing things back to the wild. So Amazon like doesn't care. They'll find someone to use that computer, right? Punchline to the WordPress story is I gave it like a $1,000 an hour computer or whatever, and it still ran just as slow as it did on the, $50 a month computer. So WordPress not written very well. So anyways, question so far. Boop boop boo. Okay, cool. Anyways, I'm going to talk a little bit about cloud architecture. And this is sort of how people go about writing applications in the cloud. And you generally start pretty basic, right? So if we start over here on the left, we have simply a computer with a disk. And it's like, okay, plop, 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 like this works. And then after a while, you like, you generally always want to put an application load balancer in front of it. And what that does is allow you a lot more customization back here, right? Like, and we're going to talk about this more over here. But the first thing you do generally is you put an application load balancer in front of things. Application load balancers allow you to create rules. For instance, like, hey, if v1 is in the URL, go to this computer. But if v2 is in the URL, go to this computer, right? So it allows you rules. It does what's called SSL, sort of retransmission, and so if the browser talks to the load balancer, it does all the encryption and decryption of stuff here, and then it just sends it over the wire. Whether it's encrypted or not is up to you. But most of the SSL stuff is done here, so you're not getting bogged down here. The funny thing is, over the past 10, 15 years, uh, the people who've made chips, CPU chips, have started to put like on-chip encryption algorithms so that basically it speeds up encryption by about 4 times, right? And now all of a sudden it's like, oh, we don't even need that over here. We need this over here. And all these things are just EC2 instances that have been customized to be a certain thing, right? In this case, it's a load balancer. But if you look at where it's actually running, it's running on, in the EC2 farm in that data center. It's just running a different set of software, and that's pretty much like most of this stuff, right? So, anyways, uh, so it also helps for secure web traffic. So again, with SSL or TLS, you have to have a certificate and you have to have a private key and all that. As soon as you put that application load balancer in front of your EC2 instance, you don't have to deal with any of that, right? I mean, you do, but again, rather than logging into this computer and like customizing it so that it understands encrypted web traffic, you just click a button and magically this one does, right? So you're not doing any customization. You're not paying someone to sit there and fiddle with your Nginx or Apache web server configuration. Nope, you're just literally clicking some buttons, right? So, anyways, once you get this load balancer thing there, you can do this thing called auto scaling. And so AWS, Azure, all these people sort of had realized like from 9 to 5, for instance, my website is very busy. And then people go home, right? And so auto scaling basically adds and removes computers based on traffic or any sort of criteria. And this, again, this was something that Amazon had to do for themselves, right? Because Amazon.com is one of the biggest e commerce sites. It is now the biggest e commerce site in the world. Um, they had to do this. And so once they figured out for themselves, they just basically started selling it to other people. So, for instance, you might have an application that runs 9 to 5 with 2 computers, and then at 5, it just switches to one computer. It might, be 4 computers during the week, and then on the weekend, you might change it to one. And to the end user, they don't know anything. They hit this load balancer, and this load balancer just knows I go to these servers, right? Now, the one interesting thing here is that you have to understand that uh, this load balancer does sort of keep track, like customer A is talking to this computer, and it has to consistently send traffic from customer, A or IP address 1.2.3.4 to this computer. Because if you send it to this one and then this one and then this one and this one, um, there are ways to keep these in sync, but it creates sort of a data affinity problem, right? Like if I'm here, my data is here, and then all of a sudden if I'm like here, this guy has my data and this one doesn't. So then he has to either generate or pull the data from the database. And then all of a sudden I'm here. So there's a stickiness involved here. And if you've ever heard of something called like Elasticache or Memcached, which is I think Facebook invented Memcached. It's basically a data storage, almost or like a memory sharing service between these. So in the autoscale group, you might be like, yeah, on all these we put Memcached, and then magically we can pool each other's memory. It's still not as ideal as just having your traffic stick based on IP. This customer has this IP, they go to this computer, anything with this other IP goes to this computer, blah, blah, blah. So there's a little bit of a stickiness there. And you'll notice one change, back here, I just had this disk, right? Well, each of these EC2 instances have a disk. I didn't put it there because it's somewhat irrelevant at this point because I need them to share data. If they each have their own disk, they each have their own data, and that isn't ideal. So I could do Elasticache, which is very common, but also for data that is more persistent, instead of a disk, I use a database. I could theoretically, and I'm sort of saying the same thing over again, just build another EC2 computer and load it with database software, or I can do things the Amazon way. Click the RDS create button, and magically I have a database. And if it's all in my virtual private cloud, and I have done a little bit of rudimentary networking, uh, that it can all talk to each other, and it's sort of private. There is So interestingly enough, the way you architect this from a network level, the only thing that's actually sitting on the internet is this load balancer, right? Customers hit this load balancer, and the load balancer acts as almost like a reverse proxy where it sends the traffic here, but once it goes here, this is all private network space. So you generally would have this on the public, you would have one private network here and then another here. And this thing would be configured that it can only talk to this. And this thing would be configured that it can only talk to these computers. That way someone can't hack your load balancer and get all your data, right? The most they can do is get to your EC2. Give me a second. I have a nice can of ginger ale. I didn't realize how long this is going. I am going a little slow, but I'll just take more time, right? It's not like we're on a timer here. Okay, so then the final sort of evolution of your architecture is you replace your computers with basically what's called Lambda inside Amazon Web Services, but all of them have serverless infrastructure. I will get to the question there, the difference between S3 and RDS in a second. So Lambda basically is like, you know what? We don't even care about these computers. You don't even have to order these computers. You just give us the code that you are going to run on these computers. And when someone hits your load balancer, we'll just find a computer and we'll just run this code, right? You no longer have to maintain this. We do it all for you. You just give us our code. If you're using a database, you'd still want your RDS in the back end, but Amazon basically takes care of all the compute. Okay, so what's the difference between S3 and RDS? So S3 is basically, it's called object storage, and it's actually, we tend to call it unstructured storage. The reason why with S3 is you could just put anything there, right? Like you could have 17 text files and then a JSON file, right? And S3 is happy with that. A RDS is a relational database, and what a relational database does is it enforces your data integrity as it's coming in. So if you are processing text, you tell your database like this stuff needs to be text. And then if someone tries to put a JSON in there, your database is like, I only accept text. Now in S3 you can't really query it, and there's a big asterisk there, but you can't really query it. Whereas with a database, there's a query language, right, called SQL, and most developers know SQL. A lot of people know SQL. It's surprising how many people have had to learn SQL for non-technical jobs, but you can basically query the data using SQL from this relational database. You can't do that with S3. S3 does have a mechanism to actually do that. It's sort of like a bolt-on feature that they added after, but object storage doesn't care what you're putting in there, whereas databases they very much need a schema and they want your data to be in certain formats, right? And that way you can query that very quickly. I think I will probably do a class on databases maybe next month because it is a class I enjoy teaching. So a lot of these sessions I've done before. So anyways, so I did sort of want to write down like the tasks, right? So whether you're doing things the old way or the new way, if I wanted to host a website, right? RyanITBasics.com. I'd have to procure a computer, whether I buy it or whatever, or get it in the cloud. I log into it, I write code, I test code, I enhance it by adding a load balancer, I enhance it more by auto scaling, I enhance it more, maybe RDS, maybe Lambda, maybe some other stuff. And then step 9, notice I forgot all the security steps. I probably get hacked. Make sure to do your security work. All right. So this is for some reason I decided to put a slide in here about domain names. So domain names: Google.com, Ryan IT Class, ESPN.com, etc. These are sometimes called top-level domains. You can get them from any registrar. Like GoDaddy is the most common one. It's really simple. Registering a domain is pretty much you just give them contact information and a set of DNS servers. And I think I talked about DNS servers last month, so I'm not going to talk about that. And then magic and of course money, and then they just insert you into a database, and now magically you own a domain name. Now, if you own a domain name, you need DNS servers. Which we'll talk about. Anyways, AWS also sells you the service. You can register your domain name through Amazon Web Services. You can also register domains if you're doing business in China. So China requires what's called an international. It's an ICP license, international something. I don't remember. International. It doesn't matter. Anyways, so if you're doing business in China, generally you don't want to use AWS because AWS doesn't handle China very well, even though they have data centers there. So you go to Alibaba and you're like, here's my ICP, give me a domain, and Alibaba's like, here, have fun, right? And so, anyways, if you have a domain name, you need domain name services. Old days, you had a guy. You would call him sort of a graybeard because he just knows one thing really well. In this case, DNS. And these servers, all they do is someone goes to www.google.com, and the DNS server says, "Oh, I'm google.com, and www.google.com is at address 7.4.2.1. So please send all the traffic for www.google.com to 7.4.2.1. It's literally all those things do. And it was used to have to build them and configure them every time you wanted to change something like IP or something. Well, AWS has, created a service for that. It's called Route 53. So you can go into Amazon Route 53, register a domain, and then go into the DNS portion of Route 53 and configure the DNS so that it points to your computer that you ordered through Amazon. Okay. I don't know why this says log in to computer. I didn't catch that. But anyways, some of the security stuff. So security groups, I think I wrote this in my slides twice, are used to allow access over the network, right? So when, for instance, if we go to this architecture right here. And so I'm on the internet. I'm here. I want to talk to this load balancer. This load balancer is the load balancer for RyanITClass.com. This might have, definitely will have a security group attached to it that says only let in traffic on port 80 and port 443, right? Those are the web ports. It might have some extra rules that say like, hey, block any traffic from 6.2.1.5 because that person is, been trying to hack my computer and I am just going to block them, right? That is that IP address. So you have these security groups. They act as the network firewall, right? Oh, one more. So The security groups are used to allow access over the network. Your IP must match a security group rule to be allowed. So a lot of these things, again, um, Amazon will either have a service or a wizard to help you configure this. So you're like, man, I don't know what port this stuff runs on. Amazon's got a wizard for you, right? While you're creating your computer, in Amazon, it'll be like, hey, what is this thing for? And you might be like, web server, and it'll be like, all right, cool. Let's open this. And what was your IP? Okay, we'll open port 22 for your IP only. So, anyways, services are run on a computer itself. If you try to connect to a computer in the cloud and you're getting connection refused, uh, generally what that means is the security group is letting you in, but the service is not running, right? I'm going to use port 25 as an example. If my security group says, hey, don't allow any traffic in on port 25, if I try to connect to port 25 on that computer, it will just hang because that computer never gets that message and never sends a message back that's saying like, oh, I'm not running anything on that port 25. If you connect to a computer on the cloud and you get back a connection refused, that means that the security group is letting you in, but the computer doesn't have that service running. Right? And of course, if you're trying to log in and you're getting a permission denied or access denied, that means the security group is good, the service is running, but something's wrong with your credentials, right? So it seems basic, but a million times in my life has someone been like, check the firewall on this thing. And I'm like, oh, what's the error message? And they're like, I can't log in. I'm like, yeah, but what's the error message? And they're like, it's permission denied. Check the firewall. I'm like, it's not the firewall. You got past the firewall if you're getting a permission denied. So I will say, so I've talked about Linux and I've talked about TCP/IP for these classes. You can get Windows servers in the cloud. Of course, Azure is a big provider, and you give them to Amazon, but you're paying extra, right? You're paying for that Windows license. We're trying to do things cheap, so most of the stuff you build in the cloud is going to run Linux because it's free. Linux, you just pay for the support, and the funny thing is, you pay for the support because you're paying like the system shader like an extreme amount of money to know all this weird gray beard Unix stuff, right? So with your security groups, you're going to have to open up port 22. If it's a Linux machine, if it's a Windows machine, you're going to have to open up 3389. That's remote desktop RDP, remote desktop protocol. And you want that to be as closed as possible. So you generally want to open it for your IP either way, but not open it for everybody. And then a lot of times there's little tricks people do, like they'll put one machine in front of their other machine, so you have to log into that machine to get to the other machine, so that the places where the data is most secretive, you have to go through some hoops to get to it. So if you're doing Linux, you have to learn to do SSH. This program called PuTTY if you're on Windows. OS X, they just come with SSH, and Linux machines come with SSH already on it. But we're pretty used to using passwords, right? Passwords are sort of going by the wayside, especially when it comes to like server infrastructure. So generally, what happens is when you very first configure your SSH client, you create what's called a key pair, and you have a private portion of it, and then you give the public portion to your servers, right? And without the full key, can't log in. So you keep the private one very private, and then you just use that combination to log in. I could do an entire class on that. So if it didn't make sense, that's fine, because it doesn't make sense until you do it. All right. So we will talk about load balancing. I think I talked about most of this. Yeah. One good thing back here, by the way, with this application load balancer, I didn't talk about this. You can easily replace the instances behind the load balancer without the end user noticing, right? So a lot of times, like if you have a new version of a software, you might create another, you might either clone this or create another one just like it with your new software, right? And you can even do things like, oh, split the traffic 50-50, right? So some people are getting the old version, some people are getting the new version. Uh, and you can sort of like use data and analytics to see like, okay, do people like the old version? Do people like the new version? So sometimes when you see features for like Facebook or something, and only certain people get them, a lot of this is configured in like application load balancer session data. Like, oh, this person is entitled to like this view. They get emojis. They get the care react. Therefore, we're going to send them to these computers over here. Like this load balance can do that. And then when you're ready, you can just remove this, right? And this thing will just keep routing traffic over there. So the load balancer keeps things sort of seamless as you do work back here. Uh, so like load, blah, blah, blah. Yep. Also, they're called load balancers because originally they were used for, okay, if I'll use AT&T.com as an example, right? Back in the days when computers weren't as fast and AT&T.com would get a pretty, high demand because it was one of the very first websites. Um, so someone had to invent something that would uh, sort of take traffic and route it to different computers so that they all had an even load. So that's why they're called load balancers. Boom. So we're going to talk about auto scaling. I think I did a pretty good job, but auto scaling groups add remove computers from the target group that a load balancer routes traffic. So I don't want to go into target groups too much because it's a little bit confusing. But basically, um, in here, you can say, all right, route data to this target group rather than this auto scale group. And then inside that target group, there is an auto scale group. And you say, why would you do that? And I'm not going to explain it because it's complicated. So, anyways, but you can, as I said, scale up, scale down. Does your application crash all the time? So, this is actually a pretty cool thing. I really like what Amazon has done with this, and it's pretty prevalent in all of them. It used to be um, if one of these computers died, all of a sudden uh, this thing would try and send traffic to it, and all of a sudden we'll say like 50% of our customers are now hitting this bad computer, right? So now there's what's called a health check. And so all these, when you're writing your application or buying your application, most of them now support uh, health checks, right? One of the things you do is you write what's called a little status check. And so this thing constantly hits like slash status of your application, and your application reports back like, I'm healthy, I'm good, I'm healthy, I'm good. And then if any of the things that this guy needs becomes unavailable, it returns it's unhealthy, and the auto scale group will just get rid of it and create a new one. Genius, because now things like in the past you had to sort of keep track of how much memory your application is using and make sure like, oh, there's no memory leaks. Like, I need to make sure that I free up the available memory so that when people make a call, I'm not slowly increasing my memory footprint until I've used up all the memory on the server. If I use up all the memory on the server, that's fine, because once this thing becomes unhealthy, it just gets replaced. So you're not doing all that work of making sure your code is perfect. Okay. Also, worried that one data center, they're called availability zones, or AZs in AWS, might be unavailable. They can also do things where they can put this one in one data center and this in another. And So AWS has this concept I didn't really talk about called regions, right? So they have, for instance, US East 1 and US East 2. US East 1 is in Virginia, US East 2 is in Ohio, right? And then inside those regions, they have availability zones, and each of those sort of represents a data center. So you might have US East 2A, which is in Hilliard, and you have US East 2B, which is in Upper Arlington. Or actually, I think it's in New Albany. Anyways, another interesting thing is that those A's and B's actually don't mean anything. US East 1A in one Amazon account might be US East 1C in another. That way, people can't all stack into one data center. They theoretically have no idea which place they're in. You do find out very quickly when you're in one when it loses power, though. But that's why they give you the option of scanning, having one in one data center and one in another. And then the funny thing is, Amazon does not guarantee that your server will stay up. You think they would because that's what they do. What Amazon guarantees is both of those will most likely not go down, and that's all they guarantee, right? So they don't give you SLAs, they don't give you anything. If you complain that, oh, my Hilliard, the stuff I had hosted in Hilliard is unavailable because of a power outage, Amazon will literally go back to you and say, like, we told you not to do that. Instead of building one big computer in Hilliard, build two smaller computers, one in Hilliard, one in Upper Arlington. And they're basically looking at you and say, we told you this. We are not going to credit you. We are sorry you are unhappy, but also you suck at your architecture, right? Especially because the fact is, with all the scaling logic, you can have tiny computers that are half the size of that you could actually buy, right? You can get a computer with half a CPU in it, right? It's fine. You're sharing that CPU with someone else who needs half a CPU. So, uh, security a little bit. So, VPC, virtual private cloud, could be used to keep things separate from each other, especially if you're, inside one AWS account. Like, let's say you're building two different applications that are totally different. You might create two different VPCs. They can still talk to each other. They just have to leave the private network first. So this keeps your stuff separate. It's a good idea. And things inside a VPC generally can talk to each other better than things outside. Okay. Inside of VPC, you can create multiple networks. You can use private networks for traffic in between your servers, and then use public network for things coming from the internet, right? I sort of just showed that on the architecture before. What you think of as a network firewall is called a security group in AWS. It is simply a list of what IP addresses are allowed to talk to your computer. This is the most important thing about the cloud, and I talked about it. Encrypt your data, right? Like, I know you think that it's your computer. Um, you have no physical control over it. Things in your lifetime could get very weird. Someone could go in there with a gun and request all the hard drives. You have no control. So make sure you encrypt everything that is sensitive. And there's again, Amazon has ways to make it easy. There's literally, if you're creating storage, you can say like encrypt, right? Now, if you just click that encrypt button, they are going, Amazon's going to manage the keys, the encryption keys and things. That is good enough for an auditor. It might not be like a PCI compliance auditor. It probably wouldn't be good enough for a financial company, right? Someone who deals like JP Morgan or somebody, right? In their case, they have a whole standard FIPS 142 that they have to do when managing their encryption keys, right? They have their own freaking standard for it, right? So at that point, you're like just clicking the little encrypt button probably isn't good enough. You can get a cloud HSM hardware security module. Uh, so they'll rent you your own HSM that you can manage for your keys. It's in the cloud. Now, again, maybe you're like, no, that's not good enough. So, like the ultra secure places, they have their own on-prem HSM. So all your data is in the cloud, but it's all encrypted with the keys that is in a security module that is in your office. So if someone, walks out of Amazon with all the hard drives, it doesn't really matter. They really can't steal the data unless they get onto these servers themselves, which your security practices should make so you can't, right? Cool. Thanks, Crash Test. Anyways, so, and I've seen these things, SafeNet makes them. It actually, Killer Queen reference, because I know there's at least one person here who plays the game Killer Queen. Those little cabinets have a Jamalta HSM in them. It's like very expensive, but all that thing is like a tamper-proof encryption key, right? The key is never leaves, right? So the HSM actually does the sort of decryption of the data, in a way. So yeah, in that case, like someone could literally steal the entire computer, but if they don't have that little thing, they can't boot it. In the case of like a video game, also the Fast and Furious games have them too. So in a country that is notorious for making knockoffs of things, right? They will go, they'll order a Fast and the Furious machine, they'll pull the hard drive out and they'll copy it and they'll make a bunch of bootleg Fast and Furious machines, right? Because they have the important part, which is the actual code. Having that HSM makes that impossible. You can't you need another one of those little thumb drives. So anyways, this cute little thing, little security thing from XKCD. Hi, this is Shun School. We're having some computer trouble. Oh dear, did he break something in a way? Did you really name your son Robert, single quote, parentheses, semicolon, drop table students, semicolon, dash, dash? And of course the mom's like, oh yes, little Bobby Tables, we call him. Yes, we've lost this year's student records. I hope you're happy. And I hope you've learned to sanitize your database input. So basically what this is saying is they went to insert the name of the student into the table. The code they were running was just like insert this into table. But what it inserted was the end of the statement, right? Insert set name equals Robert, single quote, parentheses, semicolon. And in the SQL programming language, when you do this, it starts a new statement, and the statement right after that is drop table students, right? So the program thought it was just going to insert some data, but it got a little more than it wanted. All right, so the future is now. Serverless infrastructure is slowly making way. If the computer system is virtual and the operating system does nothing but run a single application, why bother with an operating system? We originally had something called JEOS, Just Enough Operating System. It was basically like, how little can we give the operating system, right? Like literally no tools, nothing. It just runs a program. And now that's basically become to fruition because now you can basically just be like, here's my code, and Amazon will find a place to run it. You don't need your own computer. All right. I will sort of show off the interface before we do the last slide. So here is, let's make this a little bigger. So I signed up for a free Amazon account. It's called Butts69420, right? It's my free account. That's not good. Anyways, so my free account. Here we go. Services. All services. So there's a lot of stuff in here. Backup stuff. There's a better list. Oh, here we go. Over here. All right, so these are all the most common ones that you can get through Amazon, right? As I was saying, like EC2 is the building block of everything. And then EC2 Image Builder is where you would go to build operating systems that you would put on your EC2 if you didn't want just the standard Amazon Linux 2. So what a lot of people do is they build an Amazon Linux 2 machine, and then they might make some tweaks to it, like maybe they need a certain security policy applied, right? So they make those changes and then they snapshot it and make it an image, and then they use that to build their computers from then on. So we have containers. Containers are basically little small programs. Well, they're big programs, and they, instead of running on an operating system, they run in what's called a container service. In this case, Elastic Container Service. It's a whole nother thing. We won't talk about it. S3. So we have our storage here. S3 is object storage. It is very common. A lot of people use S3 storage these days rather than like disk drives and things. You are sort of abstracted from like the drives and things. Literally, you're just like, put a file here, and it'll just put a file there. It's pretty cool. S3 Glacier is also cool. So I was talking about how Amazon, it's easy to get expensive. With S3 Glacier, one of the things you can do is say, you know what, like if I haven't touched my data in a while, put it on cheaper storage. Or with Glacier, put it on tape. So if you have, for instance, a requirement to archive data, but not necessarily need it, S3 Glacier is perfect. It's like 1/10 the cost of S3. The one problem is this is how Amazon gets you, which is beautiful. So it's 1/10 the cost, but if you need that data off of Glacier, if you need it restored, that's where they're charging you, right? So it's cheap to store it. It's expensive to get it back, and it's actually not expensive to get it back if you're patient. So they basically say, listen, if you'll wait a day, you can get this data back pretty cheap. If you need it now, you are like, any savings that you had by using Glacier are gone because it's so expensive to get like right now. They have, I think, 3 tiers. It's like 24-hour, within 8 hour, and now. And you don't want to do now, right? So we have some database. RDS is your standard. A lot of people use RDS. So if you need just a generic database, RDS is the way to go. It is basically a MySQL database, right? They just fire up computer, load MySQL on it. You don't have to do anything. You just get the RDS database. DynamoDB is a key/name database. If you're doing very simple things, DynamoDB is great. It can't do anything relational though. And then there's Elasticache. I was talking about that earlier, or Memcached, same thing. There's a lot of stuff for migrating from your standard data center model over to Amazon, right? So the AWS Snow, if I remember correctly, where they send you what's called a snowball. Like literally, they send you basically this giant drive. You load all your data onto it, and then you ship it back to them, and they put it into S3, right? So then, it's faster than just copying everything over the network. I didn't know there was a mainframe thing. That's pretty cool. All your stuff, your Route 53, your content delivery network, your VPC, bunch of stuff here. I'm not going to go over the coding stuff. One of the more interesting ones. So AWS RoboMaker is real cool. Amazon has their own sort of Internet of Things, which we'll talk about there for robot automation and robots. You can, through AWS, get time on a satellite. So they have Amazon Ground Station, and Amazon sends up satellites, and you can put your code or whatever up there. You do have access to quantum computing. Amazon does have quantum computers for rent. I have never done it because it's too expensive for me. It's too expensive for who I work for. Um, so a lot of stuff for auditing, which is very important when the auditors come in. Media services, you can generally put things into S3 and stream them that way. But there's also like if you wanted to create Netflix from scratch, some of these things would work. Machine learning. So as you can see, Amazon's really into getting people to use machine learning and AI. Amazon SageMaker is their biggest one. So if you're like, man, I need to do machine learning to figure out accents, how people talk, right? You would basically get an Amazon SageMaker instance, and then you would load all your data into it. If you don't know how machine learning works, basically you give it a bunch of questions and a bunch of answers, and then sort of linked in the computer then like looks at, okay, like this is an apple, this is an apple, this is a pear, this is apple, this is apple, and it's developing in its head like, oh, apples are red, right? Every time I've seen this apple, it's red. And then maybe you put in some green apples and you blow its mind, but it creates this logic. The more input you give it, the better it gets. And then after you've done that, you do what's called like a sort of a blind test where you give it a bunch of pictures and it identifies whether it's an apple or not. And then you look where it got wrong and you correct it. That is machine learning, how it works basically. So they give you all the tools to do that. It's becoming a big thing. Amazon Athena is really cool. I think I talked about it. Like if you just need to analyze a ton of data, boom. AWS Glue works with Athena. And then Amazon Redshift is a lot. I'm surprised it's not in the database section, but Amazon Redshift is like RDS, except for it is for giant sets of data. So more for like your uh, data warehouse than your database. Um, Generally, like Redshift is a ton more expensive. People who are doing like Tableau and stuff like that, those are all words you probably like a lot of you don't know, but they are connecting up to Redshift instances and running queries. Let's see. So security, lots of security stuff. See, Cloud HSM's there, web application firewalls. This is stuff that as your company grows, auditors are going to ask about these things. And again, the old days, it was a pain in the butt, like a secrets manager. So what that does is, let's say you have, a database and it talks to, your application servers. One of your defense layers is your firewall, but the other is the fact that there is a password on that database, and the only way those servers can connect to that database is if they know that password. Well, you could put the password on the machines themselves, but then if someone hacks those machines, they have that password, they can connect to the database. So rather than that, they basically allow the machines to get the credentials from Secrets Manager, and then they connect up to the database. So the password itself isn't sitting on the server. The servers just have access to get the password. So does it help? I mean, if you know how to use Secrets Manager, you can then find a way to get it, right? But it is what's called like defense in depth, right? Adding another layer. Now, rather than hacking the computer, they now have to then use the computer to get into Secrets Manager and then get that with that password connect to that database. So they do give you lots of cost things if you actually want to look at what your money is spent on. One cool thing I didn't talk about EC2 is as the computer resources get released, um, you can bid on compute time. Like basically, let's say you have a job that needs run, it's not important, but it will cost a lot of compute time. You might put in a bid that says, you know what, I will give you 50% of what you normally charge for compute time, but you can give me that time whenever you want. And so Amazon's sitting there, like, 9 to 5 happens, uh, you know, computers are being released, and Amazon's sitting there, and it's like, oh, not a lot of people are using the computers after 5. I could make nothing right now, or I can make 50% of what I normally charge by allowing people to rent these computers. So you can basically put in lowball offers for compute time and totally rent cheap compute time, which is great if you have like a SETI or something. It wouldn't be useful for mining or anything like that, though, unfortunately. So they have a lot of things for Internet of Things, and they do have like Amazon has their own sort of deployment model for game development. You can do a lot of basically servers similar to what Microsoft offers people, and now Google. Um, so Amazon has something similar where they're like, oh, you wrote a game that's a network game. You need network servers. We can do that. Oh, you need to deploy that software. We can do that, right? Oh, and there's Amazon Workspaces, which is another thing in it, Amazon Web Services. So let let's say, for instance, we have this remote workforce now, right? Um, Rather than sending them computers, you just say, hey, use your computer to connect up to the Amazon workspace. And then the Amazon workspace is just a remote desktop. You can do your work there. It has the tools you need. It might be located closer to the data, that sort of thing. So yeah, I will very quickly create a computer, I think. So launch instance. Okay, so we're going to call it Ryan server. And it doesn't really matter. Applications and OS images, right? So it gives you all these options, right? And there's plenty of them. There's even OS X. We'll go with Ubuntu, right? And there's different tiers as well, right? But we're gonna go with the basic Ubuntu 22. I can get my option here. I can get ARM architecture x86. We're gonna go x86, and then what size, right? We can go. I'm in a free account, so they're limiting some of my options, but you can see, like right here, 192 vCPUs, and there's different. Um, this list keeps going, right? And like the letter in the front represents sort of what that class of instance is known for. For instance, the R instances are known for having more memory than CPU. The C instances are known for having a lot of compute power without a lot of memory. And then the T instances are called the burstable instances because while they have a little bit less of CPU, they can burst. So what that means is basically they're like, okay, you have a T2 micro, we're going to give you one vCPU, but if you need more and there's more available, we'll let you use more, but we're only going to let you use X amount more. So you couldn't like just sit there all day and compute on it. They give you a allocation of how much you can burst. Oh, I didn't create a key pair, and they're gonna I say create a key pair. Yeah, that's fine. And so it sends me the private key so that I can configure my SSH to connect to it. I'm not going to do that. But anyways, I'm just going to use the default VPC, allow. I told you not to do this, so, but I could put my IP in there. Boom. You guys now have my IP. And again, as how it can be pretty easy to just allow this, but I don't because if I was going to build a web server, I'd put a load balancer in front, right? So and storage, I want 8 gigs of storage. I can have more faster storage. So GP3, if there's so the letters at the beginning represent sort of the class, and then the numbers represent the almost like the version. So GP, they had GP1 and then GP2, and now GP3 is the better version of GP2. And same over here, IO1 and now IO2. You sort of say, okay, why would you use GP2 if GP3 is out? Um, Security, not stability, right? You know GP2 works, so you keep using GP2, and then maybe in your test environments you start using GP3. You use GP3 for a few months, and you're like, okay, that seems stable, it seems fine. So you start building things that use GP3 storage. And what Amazon does is they're like, there'll be a point where GP3 becomes cheaper than GP2, and that's their way to get people off, right? Get people off GP2. All right, so launch instance. So here we are. And boom. I now have a computer on the internet. It is about to run. And same thing, we go to RDS. This is, I thought this would be 1 hour. It looks like it's a 2-hour class. I apologize. But same thing. I need a database. Boom. I can choose the engine. If I remember, Aurora is, yeah. So it is like either one of these, but it's Amazon's version. A lot of people go with MySQL or Maria, which is it's basically a newer version of MySQL. So MySQL has a commercial version, and Maria is sort of like the free version, I would say, that they created. Okay, and then different tiers. I'm going to go with the free tier. I'm going to call it database 1. Throw a password in there. What is that? There we go. Okay. Boom, boom. Never. Storage auto scaling seems you'd think that'd be a good idea, but again, they allow you to make things more expensive. They don't always allow you the ability to shrink. So storage, you know, adding more storage to your database sounds good until you look in there and you're like, oh, actually, I'm really archiving a bunch of crap, and I've been paying more and more because I've been archiving a bunch of stuff I didn't need. Right. So, anyways, hopefully, create database. Boom. So, with a series of clicks, I have created a server and a database. that used to take about 6 weeks. So, anyways, that's it. There we go. I appreciate everybody. I'm sorry it got so dark. I forgot to turn the light on. But anyways, if there's any questions, feel free to ask them in the chat, or just hit me up, Brian Vile on Facebook. And if you have any recommendations, I will say don't subscribe to my YouTube, and the reason why is because I upload things to YouTube almost every day, none of which would be interesting to you, right? But I do have a playlist of just these, so you can just go to my YouTube, Brian Vile, and find it. Yeah, I think that is about it. I appreciate everybody. Have a good day.